Okay, remember that we said you can either change temperature or you can change pressure in order to change the phase. So what we have is a phase diagram that shows the combinations of pressure and temperature for different situations and what phase those would be in. Now, phase diagrams, just like heating and cooling curves, are unique to those individual substances. So these lines that are defining our different regions might change just a little bit depending on what the substance is. So yes, you're going to want to copy this into your graph or into your notes. Okay, so let's label some of these parts. Notice that there's 3 regions of space, and that would represent the 3 phases. This phase over here, which is at the colder temperatures and higher pressures, would be the solid. So the higher pressure is forcing those molecules closer together. The low temperature is slowing the molecules down, which is what solids have. In the middle here, we have, again, kind of high pressure, but a little bit higher temperature. So the molecules are moving a little bit more, but they're still kind of close together. So that would represent the liquid. This bottom area down here that kind of just fills up the bottom, cold temperatures, but really low pressure. So we're not forcing the molecules to be near each other. And then very high temperatures and pressures would represent our gas because we're allowing them to expand and do a lot of moving in this area. These lines then represent the phase changes. So if we look at E going to C, we're going from a solid to a liquid. So when we cross this line, this border between solids and liquids, we would be melting. But if we go from C back to E, we would be freezing. So that represents the melting freezing points. And remember, those 2 phases exist at the same time. So at that particular point, it's going to be melting and freezing. It's just what's happening with the potential energy, whether it ends up as a solid or a gas. Going from C to D, we're going from the liquid to the gas. So that's boiling. And then if we go backwards, D to C, that is condensation because you're going from a gas to a liquid. Those 4 are on our heating and cooling curves. Solid straight to gas and gas straight to solid is unique for just the phase diagram. So our heating and cooling curves don't show these 2 phase changes. So if we were to go from a gas straight to a solid, that would be deposition, and then going from a solid straight to a gas would be sublimation. An example of deposition, because most people aren't familiar with that, is when the water molecules in the atmosphere touch a really cold blade of grass and automatically form frost. That usually only happens when it's super, 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 super cold outside. So we're talking like in Canada and the northern states. Here in North Carolina, we don't really have that phase change occurring because we're not cold enough. Sublimation, going from a gas to a from a solid to a gas, is what dry ice does. So, you buy that really cold dry ice and then it fogs up, but there's no liquid there. That's sublimation. That's your dry ice. And then we have these 2 points here where all 3 phases meet at this particular temperature and pressure is called the triple point. Triple point because of the 3 phases that are coexisting. And then way up here for B, that spot, that is a definite end to the line between liquid and gas. That is called the critical point. Beyond that temperature and pressure, we cannot liquefy the substance, and so it remains in the vapor phase. So this line right here has a definite end point, but the 2 lines between solid and liquid and solid and gas don't have. They kind of continue on forever. When we look at this graph, though, we want to just focus on what we can see. We don't want to estimate or guess what's happening beyond the box that we have. So what are some questions that might be asked? Okay, when you have this written down in your notes, make sure you circle the word normal and put 1 atm. Normal means you're at a pressure of 1 atm. So if we wanted to know what is the normal melting point, we would want the pressure to be 1 atm. We would trace that over to the line that's between solid and liquid, because melting means going from the solid to the liquid. And then we would just have to see what the x value would be at that point. So if we trace it down, it looks like it's in between -75 and 0, so we could estimate -50 as the normal melting point of this substance. So right away we know this is not the phase diagram of water, because the normal freezing point would have been 0. What is the normal boiling point? Again, circle that word normal and put 1 atm. Normal means 1 atmosphere. Boiling means going from a liquid to a gas. So at 1 atm, we're going to trace that line over here to where we are a liquid and a gas, and then we can come straight down, and it looks like it's just above the 150 or maybe right on the 150. So it would be 150 degrees Celsius for the normal boiling point. Now, if this was a quiz or a test, there would be a range of acceptable answer choices. So don't worry about like, oh no, I didn't get it exactly right. It's just a range is okay. All right, for question 3, it says what phase change would occur if the conditions change from 0.5 atm and -75 Celsius. So we're going to want to plot that point. 0.5 atm, -75 degrees Celsius would put us in the solid area. And then it says at 1.1 atm and 75 degrees. So the second point that we would plot would be way down here in the gas phase. So if we change from solid to gas, that is called sublimation. So the phase change that's occurring then is sublimation. And then finally we have what phase is it in, and I can't really see, 75 degrees Celsius, a positive 75 degrees Celsius, and 0.2 atm. So 75 degrees Celsius, and we would go up to about 0.2, which maybe is right in this area. So that would be a gas, because we're in the gas region of our phase diagram. So those are the types of questions that you're going to see regarding phase diagrams.